Welcome back, everyone. Now, after the previous session, which was about defense in space, we're now talking about the environment and cleaning up space. I'm really delighted, as you can see behind me, we have Crystal Azelton, Senior Director of Program Planning at SWF, Secure World Foundation, and has 18 years of experience in international, domestic, public policy and management experience. Carol Deniel is the Atmosphere Specialist with the Earth Observation Division at the CNES. Philippe Pham is Head of Quality Performance and Governance at Airbus Defence and Space. And we're joined here by Nicolas Moulin-Fournier, as you can see here, VP of Digital Products and Services, Lookup, which is a young company based in Paris and Toulouse and protects space assets and operations in an ever-crowded environment. And in fact, starting with you, you said to me that the key thing is making sure space doesn't get more polluted and crowded. Why? Space is infinity.
That's a good question. We do say in the industry that space is congested and space is contested. There is a never-increasing number of objects in space. Just a few numbers. Active satellites have increased of 20% over the past year. That's 12,000 active satellites. If you add all the non-active satellites, the debris, the rocket bodies, etc., we are talking about few 10,000. And if you go down to debris smaller than, bigger than 1 centimeter, we're talking about 1 million pieces. Now you need to take into account that those objects are moving at something like 25,000 kilometers. So even a tiny piece like this is making a big hole in whatever it bumps into. So that's a big risk.
And in fact, when we hear that, it's actually amazing there's not more accidents involving satellites with all that debris flying around, right?
It is. I started my career a couple of years, last century, and there was probably 1-2 accidents. I was working on a sister ship of one of the first collision in space. Over the past year, in 2024, there has been probably something like 5 or 6 major events, creating a lot of debris and making the situation even worse. At Lookup, we believe that our mission is to protect space in order to preserve Earth. We do believe, and I guess that our colleagues will talk about this, that space is super important to preserve life on Earth, but we need to keep space operation something that is really a reality.
Satellites are unique and essential in the evolution of climate change research, and it's part of our common combat for a sustainable future. Philippe, you're at the heart of this.
No, indeed, sustainability takes several dimensions. Sustainability from space, space sustainability, and the sustainability of space. If I take the first one, with respect to the climate change monitoring, definitely 50% of the climate change parameters are measured from space. It's quite obvious. Global coverage, revisit, exhaustivity of the data, in particular thanks to a variety of missions due to the support and the investment of the European Community and ESA across the Copernicus program. But not only, what we do also with additional capabilities is to provide services to really make sustainability actionable. It's not only monitoring, it's also take action, active action from this data. Take the example of the Starlink service that we provide to support, to check the compliance of the supply chain in agriculture with respect to, for example, Nestlé or Ferrero on palm tree preservation, re-implementation, etc. So it's a true service which enables to preserve, to make sure of no deforestation and also of compliance of the supply chain in the domain. So you see very concrete examples of how we can use data from space, process those data, and then implement some effective services to make sure that action is taken to effectively preserve the climate, preserve the forest, etc. And we are moving to more and more capacities to support Earth observation, Earth science, develop the next capacities so that we expand the services we can provide to the users to move from monitoring to taking action.
You mentioned one. Can you give me some examples, maybe it's in the sea, the oceans, or whatever, where the monitoring has led to real changes? Because we just had the Ocean Summit last week as well. Is there anything concrete you can give me there that we've led to action in monitoring from space?
Yes, definitely. I mean, the breadth of the in-orbit capacities for climate monitoring is addressing atmosphere, Earth, sea, ice, well, the full span of the evolutions of the climate impact on those input, those data. And in particular, we continue to develop specific capacities from space to progress in the accuracy, the depth of analysis for data on ice, on Earth, on the ocean, etc. On the ocean, if I take the example of optical and radar imagery, we are now capable to go also below the surface with respect to plastic pollution monitoring, to take action as well with respect to identification and also preservation of the oceans. Of course, there are additional specific services like for fishery, for maritime surveillance, which really are expanding in terms of effectiveness, accuracy, and also time loop for action.
Interesting. Carol, just before this roundtable, I had someone else from the KNES on the military side. You're doing a lot on the sustainability atmosphere. Tell me about that.
Yeah, as listening before me, there is a lot of application which is possible using space data, and we have some example here. To have action. We know that our planet is in difficulties now, the life on the planet, not the planet really, due to our activities, and we need to take some action. That's why our governments take some agreements internationally to take some action. So we need now to follow this regulation and give some observation. For example, now for the monitoring of the greenhouse gas, there is no really fact observation. It's only a declaration of the different nations taking into account essentially socio-economical data, not real observation and fact. So of course there is many observation from the ground done by different actors, but the space observation are really very precious. And we see that it is precious to take some action, to monitor the application of the regulation, but also to understand. Maybe one of my special job at CNES is also to work with the laboratories, the scientific community, to help them to understand what's going on the planet, to take action, but also to anticipate what will be the next step behind that. For climate, for example, we know that there is from the World Organization some essential climate variable which were defined. Around 55 climate variable, essential climate variable were defined to describe the process on the Earth. Most of them, majority of them, are observed from space, and that's a very precious tool for the scientific community and for the people who want to take action and follow the regulation and the efficiency of the regulation. Because we can take some regulation, if there is no control, then it's useless.
We're going to get to the Space Act in a second, but just I want to pick up on what you said. There's 12,000 satellites running around now.
12,000 active satellites.
Active ones. But at the same time, you know, Carol and Philippe's work is helping with Earth monitoring, we need those satellites. So is there a conflict between you need them and too many?
No, we do need to have all those satellites because they are really providing a service. Some are more valuable than others, but I'm not the one to judge. What is important is that we need to coordinate all those activities in order to avoid risk, avoid collisions, and make those operations when a satellite needs to maneuver to avoid a collision, for instance, they need to do it at the right time when ground stations are available, when they do not need to have an important mission to act. So we need to, our vision is that we need to take into account all the stakeholders that are in this situation, operators, the payload operators that are the raison d'être of the satellites, in order to take the action at the right moment, at the right time, to keep the satellite make the job that they need to do while avoiding some chaos.
You would agree?
Yes, indeed. And I mean, space sustainability will go through a certain number of measures taking action. I think there were a certain number of mentioned here, but we are working on several aspects, meaning making sure that we can deorbit with a reliable and safe manner in a limited duration of time. We are working on additional capacities to ease deorbiting, like detumblers, specific capacities that we can add on each and every spacecraft to ease and secure the deorbitation. We talked about regulation and discipline. We need to have an international law which is applied, which is executed, and which is sanctioning if not respected. And all actors, in particular with respect to the proliferation, need to be conscious about that. In particular, the telecom constellation operators with thousands and thousands of spacecraft, in particular from Starlink, Kuiper, and a few others.
I was wondering who you were thinking about.
Yes, and the Earth observation satellites are only a very few and are bringing a lot of value. So we should be selective, and we should also take action to have this regulation applied.
Crystal, not everyone knows what the Secure World Foundation is, first of all. So maybe you can tell us about that. And I know you have a lot to say.
Yeah, absolutely. So this is very much in line with our mission. We focus on space sustainability policy. We want to make sure that the benefits from Earth, which are continuing to grow exponentially, are able to be received for the long term, right? So that's the whole concept of space sustainability. Do we have an environment that's safe, secure, peaceful, and usable in the long term? And when we're talking about what it takes to actually make that happen, I get asked that question a lot. And the answer is all of the things, right? And we've hit on a lot of them already, but we need better data. We need more research. We need industry best practice. We need standards. We need an ability for new constellations to communicate with each other across national boundaries. We need regulation. We need international law. We need all of these things in order to make sure that the risks that are associated with operating from space, whether it's for remote sensing or for other purposes, can continue in the truly long term. And we're at a really critical junction, and I don't think that's a surprise to anyone. That 10, 15 years ago, we were really just starting to think about these things. We were really just starting to understand that. But we've been emphasizing how many satellites there are on orbit, but how many satellites were there on orbit, say, 7 years ago, 7, 8 years ago? The number was much smaller. And the predictions for growth in the number, but also in the different types and uses, the types of companies and organizations, emerging space nations who are trying to figure out what their place is in all of this and what kind of satellites they need to run for their autonomy and their sovereignty. So it's only going to continue to grow. And obviously large constellations are a concern, but it's a much bigger concern than that as well. So what does it mean to be a good actor in space? And that's something that everyone has to be thinking about.
Carol, satellites that this gentleman here and others are making are smaller, more nimble, less expensive. Makes your job more efficient because you can do a lot more pinpointing on climate change, right?
Sure. I think if we want to for example, continue to be able to do some research from space. We need some satellites. Research from space is only a few parts of this number of satellites that was mentioned here. I think it's few hundreds only, not thousands, active. And I think it's a small part. And of course, if we need tomorrow to continue to launch a satellite and to be able to have good data from space to monitor our planet, we need to have some control, some protection, and to keep this space, this outer space, clean as more as possible, I would say. Because also for the astronomers, it's very important. The astronomers, for example, are very perturbed by the pollution in space. So for science to look down, but also to look up, it's very important that this outer space will still continue to be clean. But it's true that more and more people want their satellite now. More and more countries now are developing some space agency. So we really need to have more control and more regulation also on that, not only on Earth, but also in space.
I think that regulation is one thing, it's important, but we might not probably count only on this, because, you know, space is we were talking about the outer space law. Space doesn't belong to anybody. Every country can send a satellite. We've got Russian satellite, we've got Chinese satellite, we've got American satellite, etc. So it goes into the geopolitical debate, which is super complex. So I think that regulation is necessary, but also a very pragmatic approach is necessary, because time is counting. Time is counting. We believe that by 2027, between 50% and 90% of the maneuver that satellite will do will be triggered by a collision risk.
We'll talk about that more in a second. Are there any questions so far about sustainability and space? Before we really get onto the cleaning up space, any questions so far? Anybody has? Okay, there's a Space Act coming up, and like you touched on it, you need regulation. But if someone doesn't want to follow the regulations, there's not a lot you can do about that. Philippe?
Yes, indeed, it will be quite a challenge to make sure that it's, let's say, fully respected, applied in an international manner, in particular in authorizing or not the launch of compliant, I would say, missions and spacecraft. I agree that regulation will not be, of course, enough. It's to preserve the future, at least in designs and in execution. But we need also to complement the capacities of observation, of debris management, of, let's say, trajectory prediction, accuracy from the Earth and from space. I think what we do also as space systems and infrastructures, beyond climate monitoring, we are also building, you were mentioning, smaller spacecraft, additional capacities, also in space situational awareness, to enhance the space situational traffic management as well, and to check how we can implement with more efficiently some additional missions for the sustainability of space and the sustainability of Earth. On the other hand, being very precise and accurate to measure data for climate monitoring will still need, I would say, very capable instruments to do the job. Otherwise, the quality of the data will not be efficient enough to actively use and control what we do. So it's a kind of multiple action stream to make sure that we will both monitor and act on sustainability, but also on space sustainability itself.
Just before we come to you, just where are we on the Airbus project of harpooning some of this debris in space? On harpooning, catching it all with the net?
Well, we've been working on several aspects for space debris removal with respect to a certain number of startups, like Clean Space, like D-Orbit, like SSTL, with the sponsorship and the support of the European Space Agency and some of the national agencies to trial test some technologies. Of course, we are still at the beginning. It's quite costly. So this is why we try to, let's say, innovate and pursue several tracks to make it happen. I mentioned the detumbler, which is using the Earth magnetic field to have a kind of passive, fully, let's say, operational deorbiting capacity, in particular for small spacecrafts of constellations. So we need to really go through all the options.
Christophe, you're nodding.
Yeah, I wanted to respond to what you were saying about not everyone has to follow, you don't have to follow the rules. And to a certain extent, I think it's a bit of a misnomer to think of space as this wild, wild west. There are a lot of factors that push us to figure out how to make this work in the future. And that's not to say there aren't challenges or bad actors. But at the end of the day, there are already orbits that are difficult to operate in. And this is going to, as Alan said, this is going to rapidly increase. And so companies understand that there is a need to figure out how we're going to manage collision risk, how we're going to operate with multiple constellations in the same orbit, et cetera. So I think there's a strong push to understand that. And at the end of the day, countries are responsible for this. So as you mentioned, when you do your launch authorization, there is a process in place to look at many of these issues. And I want to say that we're sitting here, and one of the things that's really refreshing, and I'm excited to see the Space Act come out in a few weeks that you mentioned, is that I think Europe is really leading on this. It's a place where you can have a conversation about kind of the ultimate tension of space sustainability, which is how do you manage these growing environmental risks while understanding that we still want to promote and increase civil, military, and commercial activity? That's the fundamental question here. And I think Europe is forging a way forward on that, saying, look, we all know we need some of these regulations. We all know companies need to buy better data and to operate responsibly. But at the same time, we need to set standards and we need to figure out what that's going to look like for everyone. And in the absence of leadership from other places in the world, I would look here to Europe to understand that we both want to promote industry and other activities, but also figure out what an actual sustainable space environment is going to look like and what it takes to achieve that.
But Christophe, I mean, there's rules of regulating polluting in the seas, but you get oil tankers that put their waste in the ocean. And we have countries in space that blow up their satellites, creating millions of pieces. So that's just a reality.
Well, it is a reality, but there are things that are being done about it. So first of all, what I would point out is in the past, I would very much liken space to the oceans. You put it out there, you didn't see it, you didn't have to worry about it. Space is really large. That's rapidly changing. When you're talking about the near-Earth environment, you're talking about a much, much more delicate atmosphere. And I don't want to downplay the problems with climate and ecosystems here on Earth. But the physics are quite strict in space. And that does help us get more difficult players, at least to the table. When you're talking about anti-satellite weapons, when you're talking about that kind of thing, we do a lot of research on that. If anyone's interested in what counter space capabilities look like around the world, we have an open source threat assessment to have exactly this conversation. It's a free resource. It's updated every year. It's very long. With every single thing we can document about counter space capabilities around the world. And what we have found is that you're right, there has been a trend lately where we've seen a few anti-satellite tests, but those tests weren't all conducted the same. India wanted to prove that it could do it and did it in a somewhat responsible manner. Still complicated, I'd really rather they didn't do it, but they did understand what they were doing, right? Russia was a different story, but we have to have those conversations. We have to go back to diplomacy like we did 30, 40 years ago to address that. And at the end of the day, the Russians, the Chinese, they don't want to put their own astronauts and their own satellites in danger either. And you have to find a way forward for exactly that negotiation. It's not like people are blowing up geostationary satellites. I mean, there are restrictions in place and there are, norms of behavior that for the most part are respected, and we have to build on that rather than assume we can't.
Is militarizing space an issue as well? Is militarizing space as well an issue?
Space is more and more contested. A lot of actors are doing aggressive maneuvers, and that we are tracking on a daily basis. And the intentions of those guys are unclear, because that's how warfare is working. You need to get the people by surprise. So it's a super complex topic. MODs are very interested in having the best understanding of the situation, so they are very data hungry in order to understand, and they need to do their own benchmarks. They didn't have, at least my understanding is that they never have been a conflict in space yet. So it's a lot of interpolation of doing scenarios, etc., that are super interesting and that are super important. I agree that if a very aggressive maneuver happened in space, that could create a lot of chaos because collision could collide to other activities. And I think what I think is that in this topic, government satellites are in danger, well, are at risk, but also a lot of more and more commercial satellites are at risk because they've more and more have dual usages. Government are using more and more civil satellites, so that are also possible targets, which makes the equation even more complex.
No, I think indeed militarization of space is a fact, but we can take it also rather positively in the sense that more and more in Earth observation, telecommunication, and navigation, which are all using the low Earth orbit, let's say the technologies are dual use. Take SSA, space situational awareness, take a certain number of other Earth observation capabilities, and also navigation and telecoms. This advanced in terms of usage and use cases is benefiting both to the civil Earth observation, telecom and navigation, and also to the defense, meaning observing, preventing, acting. So for me, the fact that this dual use is really more and more a standard case. We cannot separate civil usage than defense usage. Look at the drones, which are high on the daily, let's say, the daily news. So I take it also for additional innovation capacities to provide the world with, let's say, more accuracy, more capacities. Then this has to be monitored also through regulations, through trades, through government to government, let's say, discussions. What I think is that still, with respect to the previous question, the proliferation in numbers plus the potential issues with number of launches as well, when we look at what is happening, is increasing the probability of issues, and the risks are growing and also are closer and closer to what could be a catastrophic effect like the Kessler effect in low Earth orbit. And for me, the focus is really the low Earth orbit preservation, because all what we use in our daily life, except GEO, is mainly coming from LEO, the LEO usage.
Carol, as you correctly pointed out, the number of climate monitoring satellites is actually quite small. As the overall, are there any new ones that you're working with or you will be working with that's really a game changer that gives us a lot more precision than before?
Yeah, this summer we will have 2 missions which will be put in space, especially for looking at the atmosphere. We really hope that these 2 missions will find a clean space in order to be able to really do good observation. The 2 instruments are on the CNES exposition, so you can see it. The first one is microcarb, is really dedicated to the measurements of the CO2, the more powerful greenhouse gas. And it is one of the main European missions, because of course there is other mission with NASA, with China, with Japan, but for Europe we are it is one of the first satellites to measure CO2. It is the data are very much weighted by the scientific community, because with this kind of mission, with a very high precision of measurement of the CO2 in the atmosphere, we will be able to understand what's going on in a better way, and how the forest, how the ocean is continuing to absorb or to reject some CO2 in the atmosphere. It is very important for the scientists. And after that, we will have the Copernicus mission dedicated to CO2 also, the bigger European mission, which will address one more step to measure the CO2 and at the precision and the imagery, with an imagery instrument in order to measure the CO2 coming from the human activities, the anthropogenic emission, which is one more step, precision and size of the pixel in order to distinguish the CO2 from the natural ecosystem and the CO2 from the human activity. And that is very important to, as we say, first to monitor the regulation, also to understand what's going on with the ecosystem, to the global warming and the saturation of the ocean and so on. So this is the next step for this summer. And the other instrument is YASI New Generation, which is a very important instrument because it helps to have some weather prevision. So not weather very, very high in the atmosphere, but weather here, if there is sunlight, clouds, or precipitation today or tomorrow. And with this instrument, we have the capacity to have some better precision of this prevision of the weather. So this is two big instruments which will be launched this summer, and we hope that in the future we will be able to continue to have such an instrument in space.
Crystal, I know you want to talk about this, and this is a good way is segging in. You have a summit for space sustainability coming up. Tell me about that.
Yeah, so for anyone in the audience, if this is this topic and policy and the technology that's being developed around space sustainability and how that supports sustainability on Earth, if that's of interest to you, Secure World Foundation, in partnership with CNES and the French government, will be hosting our 7th Summit for Space Sustainability here in Paris, October 22nd and 23rd. That's a policy forum. So it's a place where we'll take the conversation that we just had here and really dive into all of the details, what's happening in Europe, the technologies, how do we make sure companies get across the valley of death so we have these technologies in the future, et cetera. Definitely invite everyone. It's both online and in person. And if you have any questions, just let me know.
Any questions so far from what you've heard? Has anybody got any questions? One question, I only read one article on this, and it was, and so I don't know how legitimate the article was, but it said that with more and more satellites in lower orbit, there's a potential risk of blocking sunlight. Is there any truth to that?
I'm not aware of this.
That it could create a sort of a layer between the atmosphere.
Okay. I'm probably not the best expert.
Philippe, do you know about this at all? That with so many satellites in lower orbit, that could actually obstruct sunlight coming through? Or is that...
No.
I don't think the density is yet sufficient to do that. Of course, there's a bit of complaint of the astronomers to observe the universe due to the light, the reflection on the solar rays, and this kind of visual pollution at night in particular. The density is growing, but I would say not that at a point where we could be in this situation. No, I think it's rather crowded with respect to the coverage of the Earth, and when we look at the plan of the largest constellations, it's a bit worrying, and we could, through regulations, also impose a more reasonable number of spacecraft, which would mean to be higher for the same coverage and the same performance, and of course change the design, change the global layout and setup of the constellations. For me, this is a global reflection, which goes also the numbers of satellites launched, goes with the number of launches, with also the trend between Falcon 9, Starship, and the rest of the launchers, which also have an influence on the climate. And if there are some further collision risks increase, and also potentially full big launchers stages in orbit for refueling, then we still increase the risk of issues. That's for sure.
Maybe we can add that it creates some particles. That at one point, all the thing which is in the space, in orbit, are coming down, or in the outer space, but some are coming down. So they are creating particles in the atmosphere. So for now, I'm not sure there is a big effect, but in the future, if the particles are so big, then it can influence the climate. Because particles in the atmosphere are very important to reflect, as you say, the solar illumination and create a perturbation on the climate. That's true. And also, we can remember that we have the ozone hole in few decennies ago, which occur in the upper stratosphere. And we discovered that due to our activities. So maybe one day we will discover in the high atmosphere some effects which are very bad for us. For now, I don't think we do, but we never know. If we continue to pollute this atmosphere, maybe we will have some surprise.
I would also point out that if we're going to talk about the sun, long before we would get to a point where I think of a Wall-E situation where we can't see the sun from Earth, we do have a lot of concerns about space weather and space sustainability. So we're at solar maximus right now, and there are a lot of effects both in space situational awareness in particular, but also here on Earth, aviation, we're sitting at the air show, electric power grids, etc. Space weather can have a lot of effects on this. And one of the concerns I have if we're talking about preserving the future from space is whether we are taking the time and resources to fully understand, mitigate, and address the effects of space weather. There are a lot of potential missions in the works to help us better predict and not just understand the effects, but also be able to know when those effects are coming so that we can take the appropriate countermeasures, again, in space and on Earth. So that's an area that we don't often think about. It's easy to talk about debris. It's something people can understand. But I would also consider space weather very much a sustainability issue and something that we should be thinking more about if we're putting the appropriate resources in to making sure that we fully understand and address that.
It's a very good point, Crystal. By the way, Airbus is building in the UK with the UK Space Agency support the Vigil mission. And indeed, it's a very complex mission because space weather, to bring it to the next level, is quite challenging from an instrument point of view. But with respect to power grids, with respect to satellite activities and also telecom performances and capacities, it will be also a game changer to better understand indeed the full, I would say, weather span, not only the Earth weather, but the space weather, the weather forecasting from all over the place. So indeed, we need at European level to continue to spearhead innovation and next capacities in space and Earth monitoring.
Side effect, and I'm not sure everybody knows it, is that space weather has also an impact on how satellites are orbiting. So we do need to take this into account in our models to then predict and have an accurate vision of the space domain.
In preparation for this, you said to me that your company, Look Up, is not here to clean space, but to avoid the situation getting worse. What can a small startup like you do that the big guys can't?
I think that one key thing is that we are a young company that has been built with a very precise and ambitious vision that is being carried by the two founders. And we're here to implement it. And this is a core mission of this company. And we dare to implement it, and we dare to do it, which is a comprehensive vision from, awareness of the space situation to putting this into action in order to make it safe. That's one thing. The second thing is that, and in the same logic, is that we are not waiting for government organization to tell us what they need. We have in our team people that are coming from those sectors, etc., and know precisely what are the needs from the operational teams. And we proactively develop the products. We have a product logic in the solution that we are providing to the market. And we proactively develop the product. we show the product to the clients and we say, okay, what do you think? And we adapt. So that's the agile logic. And I think that's something that is unique in the market.
Last questions. Any questions, anyone? So, I think it's time to sum up. So why don't we start with you, Christelle? Give us your conclusions.
Yeah, absolutely. So I would note a couple of things. The first is that I think we've touched on how the link between sustainability on Earth and sustainability in space is so incredibly important for everyone to be aware of. And so this is my first air show. I'm walking around, I'm meeting people. It's a really exciting event. And I think that it's reminded me just how important space sustainability is to every single player here. And I say that both in a positive and a negative way. So from a positive sense, I think we're all generally aware of it. But it's easy to focus on the technology development. It's easy to figure out, I need to work on where my next round of funding is, or how we're going to adjust to the chaos of the United States is changing budgets. We all have other priorities. And so if space sustainability isn't your primary job the way it is for the two of us, that doesn't mean you shouldn't be thinking about it. So I think that the education piece, so Secure World, for instance, puts out a handbook for new actors in space for anyone who says, hey, I'm an engineer. I don't actually know what international law says about these things. We have a guidebook for you on that. And I think we all need to focus on that kind of education and then on the action. And I would emphasize that the action on space sustainability goes all the way down to the end users. Again, we tend to focus on SSA, debris, and satellite operators when we talk about space sustainability, but the reality is, if we're going to get changes, if we're going to get more resources to address this, if we're going to get new research, if we're going to have better regulation, et cetera, that means we have to convince policymakers that these are also priorities. And the only way you do that is by talking about what we're actually doing when it comes to space. And so for me, figuring out how to engage that whole value chain to be active on these issues, to provide the correct case studies, and to advocate for these is really important. And then related to that, what are the next steps? I mentioned earlier, we're at a fairly critical junction. And if we don't all actually step back and work together, we might see things that we really don't want to. And everybody's aware of that, but we're still trying to figure out what that looks forward to. And then we're doing that in the midst of incredible advancing technologies that are moving very quickly. We're doing it in changing geopolitical circumstances, which is making it extra hard because, we have the United States, which is a little unclear in its political priorities around space right now. We have Europe taking the lead in certain areas. Then, of course, we have Russia and China and all these emerging space actors. So there really is a need for global collaboration around these issues at every level. And that's what I would emphasize. And again, as you mentioned, we try to do our small part to encourage that. So if you have any questions, let me know.
Carol.
Well, I would say that I think now we have no choice. We need space for our life. All society are based now on the use of data from space. And I think even if we don't realize, our everyday life is based on tools which are fed by the data from space. So we have no choice. We need to find a solution for the future. And we know that there will be more and more satellites in space, even if we do some regulation, because now the space technology is possible for a lot of people. It's not like 20 years ago when I started in this job. So now I see that it will increase very quickly. So we have no choice. We have to find some solution with regulation and with pragmatic action. So I hope that you will find good innovation.
Philippe.
Yes, sustainability on Earth and sustainability in space are really tightly linked one with another. But we need to act now and to act quick. We are a bit too slow and we are not taking actions. We need to move from monitoring to taking actions. So sustainability on Earth has to be, of course, further pursued in terms of monitoring, in terms of observability, in terms of scanning all the parameters we can to be more precise, accurate on evolution, and also defining actions. I just described a few services that are actually or currently existing which enable to take action on greenhouse gases. I hope we will be able to take action on CO2. Microcarb is launched on the 25th of July. Meetup SG is launched in August. So let's make it work. And on the space, the sustainability in space, if it is not preserved actively, then we will not be able to carry out the rest of the missions. So we need to pursue all innovations, all actions. Should it be regulation? Should it be action in space, action from the ground? Constraining also industry, services, etc., for a long-term sustainable future. Otherwise, we will be in dire straits.
And just pick up on that. I mean, satellites are getting smaller and smaller, so what, the shoebox size now, and they could be even smaller than that down the road, right?
No, I mean, it's a combination of both. Again, one size does not fit all. For complex missions, complex instruments, you may have quite big instruments, big satellites, but we are working also with startups. We just launched a mission with U-Space for space situational awareness. We are working with Loft Orbital, providing our platforms. So it's a span of capacities with respect to revisit, with respect to performance, but also to the capacity to gather a new set of parameters with unprecedented accuracy, like CO2, greenhouse gases, etc. So we need to pursue all streams, and it will be a combination of all, which will be efficient for the next steps.
Okay.
I agree with, I'm building up on those three persons. That's super fantastic. Yes, life is, space is vital for life on Earth. Yes, regulation and international collaboration is super important. Yes, timing is super critical. We need to accelerate. And I think that we need also to interconnect the different stakeholders that are concerned by these topics. And we need to automate the decision. We need to shorten the time to decision to have something that is more actionable. So this is where we want to go, to moving from a very statistical approach of the awareness of space to be in real-time understanding of the situation, to take immediate action to avoid the major risks.
Thank you very much. This has been a fascinating discussion, and I'm also pleased to say it's the first round table which I had parity, 2 women, 2 men. So that was good. We ticked all the box. Anyway, thank you very much, everyone, and thanks very much for listening.
Thank you very much.
Thank you.